welcome back to Solve with Danny. So we are going to be practicing laws of exponents with product law and power law. And if you don't know the laws of exponents, go back and check out my quick 10-minute video on summarizing all the laws of exponents. Okay, I got this worksheet from Kuda Software, and I am going to skip around a little bit. So I'm not going to do every single example, but I am going to do maybe a third of them. If you want me to do more, comment below, and then I will do the rest of them if your heart so desires, okay? So let's write ourselves a little note up here. So when we have product law, or product rule, means we have the same base, and maybe different exponents, maybe the same exponents, but the base needs to be the same. When that happens, then that is a very bad then we add our exponents. And again, I proved that in a previous video. We're just getting nitty-gritty down into it, okay? So same basis. So I'm going to keep my base. We'll add our exponents. So we have 4 to the 4th. And I'm not going to simplify these. We just want to write these in exponential form. If you really want to know what it equals, you can slap that sucker right in your calculator, make yourself so happy, okay? We're not going to do that in this video. All right, well, let's get into something a little more interesting, like example 4. Now, again, do they have the same base? Yes. But what happens when there's not an exponent there? Dun, dun, dun. There's a cute little one. So we're going to keep our base. And then we're going to add our exponents. You technically don't have to write that step where you're showing the cute little exponents being added. But just for this video, I will a little bit till you get comfortable. Okay, so we have 2 to the 5th. Not too shabby. All right, but let's get into something more interesting here, like example number 5. So with our real life numbers, we can straight up multiply those. So the 2 and the 5, we can multiply those. That's going to give us 10. And then we have our exponent-y part, our variable part, with our n to the 4th times n to the 4th. We have the same base. We'll keep that in n. And 4 to the 4th is really going to give us 10n to the 8th. So let's try another one similar. All right. So regular numbers, we can multiply those. 6 times 5 is 30. Remember, when there's no exponent written, we can just slap in a little 1. I like when students do that because then you don't forget to add it. It's a really common mistake. All right, so we have r to the 1st times r squared. That's going to give us r cubed. All right. So that part I wrote in yellow. I would write it out, but the other step, you don't have to write that out unless you really want to. Then you do you, boo. All right. Number 7, 2 times 6 is 12. Then we have n to the 4th times n to the 4th, same base number. That's going to give us 12n to the 8th. So hopefully these aren't looking too shabby. Let's try, I like number 8. We'll do number 8. All right, so 6. Technically, this is like a 1k to the 1st. So if writing that out makes you smile, go for it. All right, 6 times 1, that's just 6. And then we have k squared times k to the 1st, same base. Add our exponents. So 6k to the 3rd power. All right. Let me know, thumbs up or down. How we doing? What's the pulse out there in the peanut gallery? Let me know in the comments because I really will adjust my videos based on your needs. Okay. So let's get into some more beefy examples. All right. Like let's scooch down to this example 13. All right. So let's take care of our real life numbers first, our coefficients. If I want to be precise, we have 7 times 10 times 8. You can slap that right in your calculator. You get 560. Now let's organize our letters a little bit here. If you're someone who really likes to color code, one thing I find helpful is highlighting like my same variables in different colors. So I'm going to do the V's in that green, as you see. And then I'm going to do the U's in blue. Aesthetically, it just helps me see the problem better. I'm a very visual learner. Okay. When writing something in standard form, you want your number, that coefficient first, and then we like to do our letters alphabetically. So I'm going to take care of the U's first. And you know what? I will write it in the color that I highlighted. So we have U cubed and U to the first, same base, add your exponents, okay? And then let's go to the V's. We have a third, a fifth, and a third. So let's put that all together now. 560, U to the fourth, V, 5 plus 3 is 8, 8 plus 3 is 11. So that would be your final answer for that. All right, let's check out number 14. So let's do our real life numbers. We have our 9s. 9 times 9 is 81, or if you want to write that as 9 squared, also fun. And let's do some highlighting. So I'm going to make my X's in green. I'll make my Y's in blue. I definitely recommend this, especially when we get into like tons of letters and you're like, what's happening? Like who's connected to who here? Okay. So X comes before Y. So we have this X to the first and X to the fifth, same base. Add your exponents. And then we have Y squared and a squared. So we get 81, X to the sixth, Y to the fourth, written out in standard form. All right, you're doing great. Color coding is very helpful. All right, so let's do our real life numbers again, and this number 15. And I actually recommend, like, in these next few examples, you should pause the video, try and solve it on your own, and then hit play when you're ready to see, did you do it correctly? So try it on this one. Be brave, okay? Be brave. So 6 times 8 is 48. We've got our M's. We've got our N's. All right. So we have M cubed and squared. We have N cubed and cubed. So we get 48 M to the fifth, N to the sixth. How'd you do? Did you do okay? I hope so. All right, let's try number 16. And again, like, be brave. Try this solo, okay? So we have 6 and 6 is 36. Let's do some highlighting here. We have our X's. Then we just have this one cute little Y over there. So we have, oops, I wanted to do that in green. So we have X squared and cubed. And then Y to the fourth doesn't have anybody, so it's just going to come right on down. All right. So we get 36 X to the fifth, Y to the fourth. So I hope you're doing okay. All right. Let's pick a beefy one. Let's get into something exciting. You're probably like, Danny, it's already exciting. What are you doing? All right, let's try number 19. So again, pause it here, press play when you're ready. So I'm going to take care of my real life numbers. So 10 times 8 is 80. I'm going to do my highlighting. We have X, X to the fifth, Y cubed, Y cubed. So let's take care of my X's. Remember, I'm going to put my little 1 there. So we have a 1 and a 5 for those exponents. And we have a 3 and a 3. So we get 80 X to the sixth and Y to the sixth. Awesome. Hopefully you're doing pretty good. Let's move on from product rule to power to a power. And again, go back to my previous video explaining laws of exponents if you need some help. All right. So we'll write ourselves a little note here. Power to a power is keeping the base. A little messy there. Keep the base. Multiply the exponents, but it's multiplying the exponents to every single piece. So be careful, because when we're looking at this first example, 2x squared, that whole thing is being raised to the second power. So really 2 is to the first and x squared. Okay, so 2 to the first is being squared, and so x squared is also being squared. So for this one, I'll break it apart just so you can see. So this is really like saying 2x squared times 2x squared, which would make this 2 squared x to the fourth. Okay, so a lot of times students will write 2x to the fourth, and it's like, no, don't forget about this cutie. Both pieces, oops, that's not a highlighter. Both pieces have to have that exponent multiplying the exponents. Okay, so very common mistake. So be careful. So power to power, you can expand it out if you want, but eventually you're going to get a very large exponent, and expanding it out is not going to serve you. All right. So multiply all your exponents. I love how we started with that one, but then this one was pretty chill. So we keep our base. We multiply our exponents. So 4 times 4 is 16. So I guess I could have written that out. 4 times 4 is 16. All right. So same thing. We're going to multiply those exponents. So 3 times 4. This is going to give us k to the 12th. And you can expand it out if you don't trust me. But that's a lot of work. Blah. Okay. All right. Let's scooch over to this one. All right, so remember there's really an exponent here and there. So on the 7 is to the first, the k is also to the first. So this 2 is going to both of them. So we have 7 squared and k squared. So be very, very careful. All right, if you really want to write it out as 49 k squared, go nuts. They're both correct. Just depends on what the directions are that you're given, okay? So this one, again, power to a power, just multiply your exponents. And for the love of God, please do not write an x for times. Don't do it, okay? X to the 6th. All right, why don't you try this next one on your own, pause, and then hit play when you're ready. All right, so remember, we've got this cute little one here. And we're multiplying everybody, all the exponents. All right. So we have 2 to the 1 times 4, b to the 2 times 4. So we get 2 to the 4th, b to the 8th. And then if you want to evaluate that 2 to the 4th as 16b to the 8th, it is all good. So again, both are correct. Just depends on the directions your teacher is giving you. And this first step right here is technically optional, but recommended, especially if you want to just make sure you're not forgetting anybody. Writing that one as an exponent all the way up there, highly encourage. Okay, so hopefully you hate math a little bit less today. Hopefully I cleared up a couple of those law of exponent rules for you. Stay tuned because I will be posting a practice with division and these laws of exponents. All right, so make sure you like, subscribe, and comment for feedback because I love feedback. So have a great day, everybody.